Hello my dear students. In this video, we'll be talking about sound. We're going to understand what is sound and how sound is produced. Students, have clapped so many times? What do you do while clapping? You hit your both the hands on each other and hence the sound is produced. Do you feel the vibration? Yes, we all feel the vibration while clapping our hands. So, the sound is produced with the help of vibration. Let me give you another example. When you go to temple with your parents, they ask you to ring the bell. So, how do you do that? The bell in the temple has a dome and a pendulum. So, you just have to strike the pendulum on the dome of the bell. And once you strike this pendulum on the dome, it is going to produce vibrations, and hence these vibrations are leading to production of sound. Similarly, when we talk about a tuning fork which has two prongs and a handle which is called stem. So let us see how does this tuning fork look like. Look at this. This is a tuning fork which has a U-shape, prongs and a stem. Now there are two prongs, you can see. When this tuning fork is struck on the rubber pad or any other object, then the vibrations will be produced in the tuning fork, and these vibrations will be given to the neighboring medium. Now let's say we're holding that tuning fork in air. So the air molecules will be around the tuning fork. The tuning fork will be always surrounded by air molecule, and hence when the vibrations are produced in the tuning fork, these vibrations are going to be given or transferred to the neighboring medium. So let's see how does this happen exactly. If we keep the stem steady and if the prongs are struck, they start vibrating. As you can see, the prongs are vibrating here. Now, to understand the state of air around the tuning fork, we're going to use this vertical lines. As you can see, once the vibrations are sent through the prongs of the tuning fork, they are sent through the air medium. Now you can see the prongs of the tuning fork are set into a periodic motion. Periodic motion means the motion of any object or a particle which repeats after equal interval of time. That is called periodic motion. So, as these prongs are now set in periodic motion in forward and backward direction, we will see step by step what happens. So, the result of this motion will be seen in the air layer. If during vibration the prongs of the tuning fork go away from each other, then the air outside the prong is compressed and the pressure there increases. Now such a state of high pressure is created in a region where you see all the molecules together, the dark region. The region in which air is at high pressure and high density is called compression. So you all can see here all the air molecules are coming together and forming a dark region. And that dark region is nothing but high pressure zone or high density zone. And that is called compression. Now let's talk about the region where the molecules are seem to be separated. Why does that happen? So, if we have the prongs set into vibration, then what happens? The prongs of the fork come close to each other because it's a periodic motion. So they bend forward and backward alternately. So in the next step, what is going to happen? The prongs are going to come close to each other. So in this case, the air molecule near the prongs get more space to move away from each other. And as a result of this, the air pressure in this region decreases, and such region in which the air is at low pressure and low density is called rarefaction. So here in this animation you can see there are some places where you find a dark region, that is high pressure or high density region, and there are some places where the layers are separated. So we can say that it consists of alternate compression and rarefaction. You know, students, in this particular transfer, the particles are not moving at all. They are remaining at their position. But what is getting transferred? The energy is getting transferred from one particle to another particle. So the energy was given from or through the tuning fork's prongs, and now they are sent through the air medium from one particle to another particle. So let's see how does this happen. This is how it happens. Look at this. There is a vertical layer of particles. They get some energy from some source. Once the energy is received by this first layer of particle, it is sent to the next layer, then it is sent to the third layer, then it is sent to the fourth layer, and then it is sent to the last layer. And this is how the energy transfer takes place when the sound waves travel in different medium. So due to the periodic motion of prongs, the compressions and rarefaction in air are produced or created, and they are propagated. Propagated means travel away from the prong. Okay, and these are what? These are nothing but sound wave, because sound wave is the only wave which consists of compression and rarefaction, and hence once these sound waves are sent through the air medium, they reaches our ear and then they fall on the eardrum, and then eardrum vibrates, and accordingly the specific signals reach the brain and we get a sense of hearing a sound. So this is how the sound is produced, traveled and heard by us. Now the next property of sound wave is frequency. There are certain frequencies, right? Because as we say, sound is a wave. So wave has so many properties like amplitude, displacement, wavelength and frequency. So what is frequency of sound? So students, we already have learned about compressions and rarefaction. Compressions are the regions where particles are crowded together and represented by the upper portion of the curve. So here you can see in the wave form, so where the maximum or large amplitude is shown, that part is called compression. Okay, and rarefaction is the region where the molecules are separated. So in a sound wave, or when a sound wave travels through a medium, it produces alternate compression and rarefaction, and a wave or one oscillation consists of one compression and one rarefaction. So once you get a combination of rarefaction and compression, you should know that your wave has already completed one vibration or one oscillation. So number of such oscillations performed by the sound wave in 1 second is called frequency of the sound wave. Okay, so number of vibration produced by a sound wave in 1 second is called frequency of the sound wave. This is very important definition. The symbol of frequency is F, and the SI unit of frequency is Hertz, because this is represented by a Greek word Hertz and letter nu. This you will learn in 9th standard. So let's say the number of such cycles that are produced in air medium per second are 512. So the frequency of that wave will be 512 Hertz, because 512 cycles are produced in 1 second. So number of cycle divided by 1 second is Hertz. Let's say there is one cycle completed in 1 second. So the frequency of that wave will be 1 hertz. Okay. If we say there are 256 number of vibrations produced in 1 second, or number of cycles are produced in 1 second, then the frequency of that tuning fork or that object will be 256 hertz. Students, we all know that there are different musical instruments. So in this picture, we have some instruments. So the first one is gong. Gong is kind of school bell which we have to hit by another object, and then what happens? The vibrations are produced and hence the sound is produced. Now then the next one is accordion, cymbal, clarinet, bugle, French horn, then piano, violin, flute, drum, electric guitar, normal guitar, trombone, then cornet. These are different musical instruments. So do you think they are related to sound? Yes, because these instruments are producing music. That means nothing but the production of sound, right? And the music consists of different notes, different frequencies. Okay, so these instruments like sitar, violin, guitar, which use string for production of sound, and instrument like flute, shehnai, clarinet, they use air blown into the pipe for the production of sound. So these instruments which require or which use air to be to blow through it or for the production of sound, these are called wind instrument. And the instrument which use string or for the production of sound, they are called string instrument. In string based instrument, the frequency of vibration of the string is changed by changing the tension on the string. So look at here. The frequency of the vibrations of the string is changed by changing the tension on the string, we have already seen, or you can change the vibrating length of the string using the fingers. So here you can see how the vibrations are produced in guitar after plucking different strings at different lengths. So this results in the generation of different notes. In the musical instrument like flute, the holes of the flute are opened or closed to change the length of the vibrating air column in the flute. And the frequency of waves therefore changes, and it results in the production of different notes. In flute, different notes can be generated by changing the way of air blowing also. So look at this, how this cartoon is blowing the air through the flute to produce the sound.